Okay, this is Sky Blue, and you're listening to the Jazz Hop Cafe. Some smooth flows for you jazz cats.
All right, everyone. Welcome back to another stream after several months of inactivity. I'm back. So this is going to be a mainly Vex kind of based stream, um, focusing on programming, making a little looping kind of animation. I have kind of examples or inspiration here that I was following along when I made it. So I'll load this thing up here. Yeah. So there's this Instagram post. This guy had shared this sketch or thing that he had made in processing. Processing's like a Java-based computer programming language, and all of their drafts or programs that you write in it are called sketches. So even though it looks like a pencil drawing, this is actually like a program that he's written. And he's inspired by this guy, Bees and Bombs. It's like a pretty notable. He does a lot of these looping GIFs, mainly using processing. I think he's been using Houdini for a little bit, or other programming languages, maybe for some more advanced kind of features. So what I was going to go into today is just making a looping version of this, looking at that original inspiration image. You can kind of see the motion that it would follow. So just it keeps expanding, and at the same time, the outer triangles shrink, kind of dissolve, and more of them keep getting rebirthed and recycled. So that's what we'll be going over today. It's a lot of Vex if you're not familiar with it. This is a good area to get involved. This is more of like a glossary. So you would just look up a function to find out exactly what it's doing. This isn't organized in like a learning method, like you wouldn't read this like a book or anything like this. You would just refer to it. If you search for it, like just search for scale, you could find all the different functions that are relating to scale. So I won't be going into very like introductory programming kind of stuff, like how a Vex program works, how it runs, or anything like that. There's a few resources I can recommend, like Joy of Vex. This one guy who runs the CG Wiki, Matt Estella, I think that's how it's pronounced. Um, this is a really good guide if you've just never written a program before, or if you've never programmed with Houdini or with Vex. So it's a nice resource to have around, or just a good kind of starting point or introductory. Let me see. They also have this is like a good thing to read, but it won't really, it's not really like a training. This is still more of like a glossary or like an instruction manual. I think this Vex cookbook is like the closest that they have to I don't know, even even this one isn't that great. So maybe just like third-party resources. I could try to share some more when I save the stream. So I started recording these locally, so I could post them to YouTube or just make them more permanently available. I guess on my Twitch channel, my older streams kind of got outdated and they yeeted them off the channel. So I started recording these locally, and then I'll try to keep all of these resources like available and just around, for people in general. So if anyone has any questions, feel free to pop them in the chat during this whole process. I'm going to get started now. I brought this 2-hour big oversized time glass or hourglass, right? This is 2 hours. So I'll put this here. We'll try to complete everything that we're doing within the 2-hour time limit. Maybe if there's extra time at the end, we can go over stuff. But this is all generally going to take, it should be probably even less than an hour. All right. So just minimize, get rid of some of this stuff for now. And then usually if I know I'll be writing a lot of Vex code, I'll usually leave this functions window open just to refer to. Sometimes people will open a pane tab or something like that within Houdini. I'm using kind of a custom desktop or window here. So I like to hide things and have more of a minimal user interface. It's the shelves, the timeline, and things like that are gone at the starting point. I do like this color bar that has like an alpha channel view, or you can just change exposure and stuff. That's quite nice. You could just find it right there under the perspective. But some people do like to maybe go into, ooh, not that one, maybe technical or something like this for programming. Something people might do is like if you make an extra pane tab of these, you could turn it into a help browser like this. And then you could get to your Vex reference or your coding functions and get the whole glossary in like the whole user interface panel. So when you're writing code, maybe you don't want, maybe you want that guy. Now you're like a very professional developer, programmer, all the information at your fingertips. So you get your language reference going here. I don't know. Sometimes this is a little bit slow. This is like I don't know. It's not as good as Chrome, the web browser, maybe. So that's why I don't like to use it. But whatever works for you, go for it. So I'll just go back to my desktop here. I like to have these floating panes and stuff like that that I can kind of resize and move around. And I'll just get rid of all this stuff that came in there. So we have an empty scene. And then I'm just going to start with a circle. So maybe I'm just going to go into my Twitter and grab that as like a reference image so we can have it just in the back of our minds as to what we're making. So I usually like to work on this ZX axis or XY, either way, it doesn't really matter. Because what we're making here is a predominantly like two-dimensional 2D effect. So we're not going to have to worry about one of the dimensions like X, Y, and Z. We'll just be working with it like it's a 2D image. So you can start with, I guess, X, Y is good. Right now, the thing that we're making is a primitive, or what the circle that we're outputting is a primitive type is set to primitive. So what that means is that this is a single data type, or it's not necessarily a polygon, it's something kind of even simpler than a polygon. So if I switch this to polygon, now you can see we have 12 points and one primitive that happens to be a polygon. We go back to this, we don't have any polygons. This primitive is almost a simpler type than a polygon. There's like things under the hood that are called intrinsics. So I think somewhere kind of very low level, this is, maybe it's this one, yeah, type name is saying that it's a circle, and then it has a transformation matrix that's basically defining its size, its scale, rotation, and all of those factors. So instead of doing it with polygons and points, it has that extra intrinsic data that's defining it. So we don't need to worry about that. We want to do more of like a hard surface modeling technique. So we'll work with polygons. And then the other thing I messed up here is maybe starting with a circle isn't the best one. So this is kind of a counterintuitive thing with Houdini, but if you want to make like a properly topology laid out circle, sometimes starting with a tube is the best way to do it. So if I orient this along the z-axis, then it's kind of the same thing. And then I'll switch this this is another thing that we can represent as a primitive type, which would just be 1 point, 1 primitive, etc. But we'll switch this to a polygon. So now we actually have points and primitives and everything representing it. And then the reason I switch it to a tube is I'll make the height 0, and then you can move one of these radius, inwards, and then you kind of have like proper topology. So if you want to make a cap or something like that with Houdini, sometimes it's kind of counterintuitive, but starting with a tube and then making it a height of 0 and one of the radii go inwards, then you have more of like a pizza pie kind of topology. But this way you just have one single like n-gon in the middle of the circle, and can be more difficult to work with. So I'll get rid of that. And then this guy, I don't want it all the way in the middle. I'll just have it halfway in. So the reason I'm doing this right now, I'm trying to break this up into like one of these rings that is splitting up. So programming is like a repetitive task. There's things like recursion or repetitiveness where you can very easily repeat the same task over and over again. So that's kind of how we'll be breaking it down. We'll just create one of these dissolving rings set up in a system with Houdini, and then we can kind of reapply that over and over again endlessly. So you can see right here the shapes we're getting are these triangles, but here we have quads or kind of trapezoids. So I'm just going to do this remesh, and then this guy will let me, if we go big enough, and then I think here I don't want 12, but 6. So now you can see we're getting closer. So the tube, I'm just using it to define these hard edges. So we have the same, I guess it's a hexagon. And then this remesh is being used to make these like equilateral triangles. So if I do a divide or something like that, there's other ways to triangulate things within Houdini, but you can see that the methods are slightly different. So I don't want these, I don't know, it might be isosceles or, I'm not sure, but I don't like those triangles as much. I like the even dissolved ones. And then the next thing I'm going to do is just apply a facet. So this is kind of an older node in Houdini. It has a ton of different uses. So it's kind of misleading, like the name of it doesn't really, it's not that clear. It's a little ambiguous because you can do a lot of different things with it. We're going to do it to make these unique points. And what that does, it's a little bit hard to see, like it doesn't look like anything changes. But if you look at the data under the hood, you could see we have 54 points after applying that operation. But before that, we just had 18. So what the unique points is doing is anytime these polygons are joined, it's splitting them and creating 2 points. And basically each of these faces are now a detached element. So maybe like this jitter is a good way to kind of visualize this. So you can see when I'm jittering these points, this is just moving each point in a random direction. You would see that all these things are detached, or they're unique faces, or each point is a unique point instead of joined, merged points between the faces. So if I don't do the unique points, then you could see that because these are shared points, they aren't unique. When I move them, they don't rip off into individual elements, and it's all just one single kind of connected tube or strip. So that's why we do this facet with the unique points. And then I think that this is pretty much all we need to get started. Turn that off for now, and then I'm just going to do a copy and transform. So what this guy is going to do, if I just set this to 0.5, now you can see we have another iteration inside of this, kind of like a nested doll, or just a repetitive kind of fractal. It's kind of nice. And we could keep expanding these endlessly. So once we get to a certain number, then you basically can't see that there would be a little hole, or like some missing, but once we shrink it by half and by half and by half and so on, like eventually you just can't visually see it. We could also switch our viewport to the front view. And now we're working just purely a 2D image. There's no perspective. This is like the orthographic mode. All right. So keep going. And the next thing I'm going to do is apply the motion to everything. So with the Vex, this will be our first actual time for this like assignment, typing Vex. There's different elements we can run over. Points is running this code on each of the points in parallel. Primitives is doing the same thing, but running the code on the faces. So a quick way to visualize that, if I just assign the color at CD, it stands for like color diffuse. And if I set it just to a random, then you need to decide how to hash the random value. You could use the point position. Now you see that because of where each primitive or face is located, it will get a random color. So if we do the same thing with points, you would see that now, because it's operating on the points, it's interpolating that color over the entire face. So that's just a little difference, like detail. It will just do one random color once, like as it processes this whole input. Vertices works kind of similar to points for most cases. Numbers is kind of like detail, but you just keep rerunning this a certain number of times. But primitive and points is what we'll be kind of focusing on, or the two that we'll be using here. So if I actually want to move the points, the easiest way to do that is with the points method. So if I just do @p plus, then you can see we're getting something kind of like that jitter, where each of these points is getting moved in a random position. If I subtract 0.5 from it, one other thing I might have to make sure is that this is a vector instead of a float. So that's just making sure that we're generating 3D random numbers with this function instead of just like a random one-dimensional number. And then the last thing I might want to do is add like a channel for the scale. All right. So then we can just click this icon here, this little toolbar, and what that will do is add parameters for each of these calls. So this CH is for channel, and then F is for float. So that's just saying when it makes the spare parameter, tell it to be a float parameter instead of like integer would be one number, or we also have like CHV for vector if you want to have 3 different components to move things around with. So we compare this now, what we've basically done is just replicated how this jitter is working. But because here we're doing our random number based on the point positions, even though we've detached these points, they still share the same position. So if we do something different to generate or hash our random number, like ptnum, we know that that will be unique even if their positions are the same. So that's how we could actually kind of, now we've basically just recreated the jitter node with a few lines of Vex. The other interesting thing about Houdini is that you can double click on these things. You do allow editing of contents. Like anytime you see the lock, that means that there's stuff going on inside of it, or it's a digital asset that someone has made or side effects has made and included with the software. So they're actually using an attribute VOP with a bunch of nodes inside of that that's generating Vex code for their purposes. If you want to right-click here, you can view the code that it generates. Sometimes if you're learning Vex, this is a good way to troubleshoot things or just learn. If you're just more comfortable using nodes, then you could visualize like the code that it's generating and get comfortable with the equivalency between the two. So this one, because something side effects has made, they've added a lot of code to kind of make it very robust and handle a lot of features. So that's why there's a lot going on. And then the auto-generated code is just in general a lot more verbose, or there's a lot more comments and variables being used than when you write it yourself. So kind of as simple as this, you can recreate some of the built-in nodes of Houdini. So now instead of doing a random number for the points, what we could just do is, get rid of this, get rid of this, and then just do this. So now we're just multiplying the point position by a scalar or a float value. So this way we can basically just apply a uniform scale to all of the points. So if you use a transform node, what we've basically recreated is this one parameter of uniform scale from the transform node. So now with scale, we have our parameter, but we can also use an expression. So if I do another multiplier, and then we multiply this by time, what this is going to do, just bring up the play bar, what this will do is convert this frames into seconds, which is, we're working at 24 frames a second. So this would be like 1 second here, or just the 24 divided by 24, which is 1. And this number will keep increasing to represent the current time in seconds. So this is just a quick way to do procedural or programmatic animation. What I mean by that is I'm not making channels, I'm not creating curves or doing kind of any keyframe-based animation. But the one thing you'll notice when I play this is that it's more of like an explosion. It's not really a linear scaling. So with this, everything's expanding at a constant rate, whereas what we have in our animation here is it's starting off really fast, and then it's like reaching this kind of terminal velocity, or it's leveling out at the top of that curve. So the way that we can kind of fix that, or to get around it, is to use like an exponential curve or an exponential factor. And then the other thing I might want to do is, like, just so that this doesn't start at 0, I'm just going to add a 1 to it. So now it won't be invisible or hidden at the first frame. So it still has that burst at the start and then like the deacceleration. But what I'm going to do is just fix that. The way to do that is you can do a power. So this is like an exponential function. And then 2 raised to this exponent. So this is a little bit more advanced math or whatever. But if I do like power of 2 to the 256, if you write it out, it kind of looks like this. I think so. I don't know. I'm not doing the best way of explaining this right now. But let me just play it. So you can see now that everything is expanding at, like, visually now a constant rate. So because when things expand, if you use just like a linear scaling factor, it won't visually scale in like a linear fashion. So what we need to do is this kind of like quadratic, I don't know if I'm using the right mathematical terms, but if we do this exponential scaling, then we can get something that visually appears to be going at the same rate. And if I click this thing down here, that will just make sure that we're playing real-time feedback, or every these frames are being played back at 24 frames a second, whereas this is off. It will just try to do it as fast as the computer can, and depending on other processes and stuff like that, it won't look to be like a steady frame rate. And then at the end, if I really want to, you can start to see that we're running out of these circles. So we could just add a few more if we really want to. Oops, I don't know how many we need to add. It might be like a floating point precision issue or something like that. Maybe you run out of, because they are so small at the start, in the middle of this circle, they might all be getting like really low numbers, and that might be messing it up. We don't need to worry about that right now. And then one thing that I can do, oh, Shades of Orange is back. Good to see you again. I finally made another stream after half a year. So one thing we can add to this time is another scalar, or another float multiplier. And then this one will be speed. Just get these quotes sorted out. So this way, now we just have a constant expansion value or number. So if I do this 4 times as fast, you'd see we're basically just going to run out of these things too early. So this is just a good way to kind of overall control things. And then just keeping these things named clearly or concisely can be helpful. You just see. So once I add this exponent, I don't need to add the 1 anymore. So this will just be expand circles. So I like to work like this and kind of just have simple operations or simple functions and just keep adding on to them. Some people will try to do a ton of stuff inside of one wrangle, but I like to kind of create these other more modular based approach of like reusable micro programs instead of trying to cram like 20 lines of code in here. So the next thing I'm going to do is just a primitive wrangle. And when you do the primitive wrangle from the tab menu, um, it's just a macro that's basically renaming it to primitive wrangle and setting it to primitives. So if either way, some people will always start with an attribute wrangle and just set it to what they want it to do. You could also just create it like that. So now the reason I'm doing it over primitives is because I want to start to figure out a way to assign a scale or figure out how these are going to shrink. So this is the next step of what we're going to do. I'm not going to shrink them with this code right now. I'm just going to kind of create a mask or visualize how they're expanding or shrinking. Hey, good to see everyone in the chat. So if you have any questions or something doesn't make sense, feel free to bug me or make any critiques. If you know of a faster way, like a better way to do things, that's helpful too. So what I'm going to do now is just assign the color, the diffuse color, to the prim num. So what this is doing, basically, it's taking this number and just copying it to the color value of these faces or the polygons. So I switched over from points to run over primitives for this because I want a single value all across the face. So when these things are shrinking, it's all the same uniform thing per element or per face instead of per point, like things would get a little janky. So you could do it primitive, and then this kind of stuff here, like, so you might not see these CD or primitive, these like commonly used variables in the help guide, but if you do go to the snippet, this page right here, this thing can be pretty useful for these. So if you go to like accessing indexing variables, then they have point num, prim num, vertex num. There's also this element num, which is kind of like a hack. It's like a hidden one that's pretty useful. I won't use that right now, but maybe we'll get into it later. And then they have like the time, these other like global variables that I was using. Somewhere I think they had like the commonly used ones. I have an old website. I haven't really been updating it too much, but I do have this like wrangled cheat sheet in here. And then this one I've tried to kind of lay out all of these default or built-in attributes. Like these things, these are things that Houdini is designed to recognize, like CD. That's why you don't have to specify that it's a vector. But if I was making up my own name and not following like their built-in conventions, I would have to tell it what kind of attribute to use. But that's just another good like resource for Vex-based stuff. So the other thing you'll see that we have is like num prim. So that's the total number of primitives. So if I divide the primitive number by the number of primitives, it doesn't really work. Like everything's black. So what I'm trying to do right now is like integer division. So it's keeping this data type to be an integer. That's also like what happened earlier when I was making my random function and I had to add a random or a vector to it. The same thing is happening here. So I need to cast this data type from an integer to a float. And now you can see that I'm actually getting like different shades of black instead of all like uniform black value. And then usually what people do is they will subtract 1 at the end. And let me just make sure I've done something wrong here. Okay, I see what's happening. So basically, because I've created so many copies, it's not getting very bright until it's so small that you can't really see it. So for right now, I'm just going to make 4 repetitions of this shape. We won't create the final one. Like we'll add all the extra inner layers at the very end. So you can see right now what this code is doing is it's normalizing the face number to go from 0 to 1. So starting right here where the face is number 0, all the way inside then it's getting to white or a value of 1. So if I wanted these to start shrinking, this kind of is a starting point for a mask or a way to generate these random numbers. But instead of like going all the way to the inside circle, I just want this thing to keep repeating for each ring. So instead of dividing this by the number of primitives, one of the things that I can do is divide it by just the number of triangles in like a single ring. So if I look here, that's 18 primitives or 18 faces. So if I switch this, if I switch this to 18, then this should be going from 0 to 1 within one ring or one repetition. The other thing that I can do is use a modulus command instead of the division. So what this does is it kind of keeps repeating things like a cycle. It's a little bit hard to explain. Like people, it's like to do with the remainder versus. I wasn't ready to explain this. So if you do a modulo search, I can't explain this that well off the top of my head, but this Wikipedia article is more advanced. One of the things people do is do a modulus 2. So this is basically saying whether the number you're looking at is even or odd. So like here, I can make these visualizers a little bit bigger. So it's saying basically, is there a remainder when I divide things? If there's no remainder, it's going to be 0. If there is a remainder, which means like numbers left over, it doesn't divide cleanly by 2. It's like 9 divided by 2, there's extra numbers left over. So if you do that by 3, then you get this kind of pattern. So it's like just looking at the numbers that are left over when you do the division operation instead of giving you the actual result of division. So when we do that by 18, which is the number of primitives, like these go from 0 to 18 for each repetition, then you can see that we get this result. And then if I divide this again by 18, then you can see for each row, now I'm getting this repeating 0 to 1. Instead of like overall, when I did it, it was starting at 0 and then getting to 1 at the very innermost ring. Yeah, it returns the remainder. I don't know. I just have a hard time explaining that or visualizing it, or I don't know. It's like a sometimes when I try to tell it to people, it's a very their minds kind of freeze up, and it's hard to to explain. Um, so now one thing that I've done that might be a little bit bad is to hard code these numbers in. Like if I am designing something to be fully procedural, now these things aren't repeating as cleanly. Um, so I can get around that if I look at this input and plug it into the input index 1 right here. So this is like index 0 and 1. And then instead of this, I can do n primitives, get that first index, and then I can do the same thing here. So now you can see that it's updating automatically. Oops. All right. So I'll just go back here to 6. So now we have our kind of offset per triangle that's just repeating for all of the rings. The other mask, or the other number that we're going to need to generate is like a kind of radial pattern that's going to choose when these things are going to start shrinking. So I have two masks or two numbers that I'm trying to generate here. One is like a global. The first one we've kind of done here, it isn't looking exactly the same because I don't have these in the correct order right now. But it's a offset per triangle of the ring. And then the other one that I need to generate is this like concentric number of depths or number of rings. So you could get it from the copy number. You could like have it bake in this attribute. But because this is like a Vex centric kind of lesson or thing that I'm focusing on here, I'm going to just do it with code. So if I take the primitive number and then I can divide it by that same number of 18, and then I'm getting these clearly stepped numbers that's going from 0. Let me see exactly. 0, 1, 2, 3, 4. So now this is a unique ID for each of these concentric circles. And then again, to fully proceduralize or automate this, we can replace it again. So it will always update and just grab this number of how many primitives are in this input. This one, we don't add the float because we want all these numbers to be integers. You could see here if I knew how to spell and added it, now we're not getting the right number. I could kind of force these to be what I needed to using like a floor operation that would be adding like the steppiness kind of back to it, but just for like shorthand or to make things look a little bit more simple, we can ignore all those extra steps for right now. So now the next thing I'm going to want to do is that this isn't expanding with the circle. So what I can do here is subtract the time. And then you could see that as things are expanding, these rings are getting moving inwards. So we want to keep this white area in the same place because this is going to be a mask that we're going to use to choose when these things start dissolving. So when it's white, these are going to be at their full scale or the full size. And then as they fade to black, then that's when they'll shrink down into 0. So the other thing that I need to remember to do is to treat this speed as a global scalar or a global variable. So I want to apply the same speed modulation or change to anytime I use this time variable. I want to multiply it by the same speed amount. So what I can do is just make another speed float value, and then I can just grab it from here and do a relative reference. So now, because those speeds are in sync, this white circles will always stay in relatively the same place. You could see without it, if I comment, and if I add more of these circles, because this speed is not compensated to be the same as this speed, the white area is growing like beyond the extents of the screen after a few seconds. So if we add that back in, now because things are compensated properly, it's always fading in the same relative like screen space kind of area. So everything is kind of making sense so far? Usually I like to create these masks and kind of like is similar to my modular based approach. Like I'm just breaking things down into simpler steps and visualizing things with the color. So I'm walking through everything like in a stepwise, breaking things down into smaller and smaller like tasks essentially. So now we have our two different color things that we're generating, but they're not affecting each other at all. So what I want to do is take this first mask that we're looking at right now and just get rid of it and then subtract it. Whoops, pressed too many buttons there. So when I'm subtracting it, now you can see that both of these are affecting the end result, or they're affecting each other, which is affecting the overall end result. So I'll just make more of these copies, and now you can see like we're getting somewhere. If I turn off my wires, turn off the grid, we're getting closer. We're not all the way there yet, but we have some of the steps done. So does this make sense to everyone? What I'm doing here is like offsetting the color value. So we are starting with just our constantly expanding thing, and then what we're doing is offsetting the mask value or the color value slightly, like just to be slightly different from one another based off of the like per ring primitive number. So because this is based on the primitive numbers, if I start to sort these in different fashions, then you can see that I'm getting different patterns as these things are fading out. We can just get endless kind of combinations by randomizing. What this guy is doing is it's just, just randomizing the primitive numbers. So my masks, or I'm basically shifting in time ever so slightly when these individual triangles are fading out based on their primitive number. So if I want to get the actual resulting animation to be in this like ordered radially or like a clockwise fashion, instead of going randomly, what I could do is sort them by an attribute. So I don't have a specific attribute to use right now, but I can do it with another wrangle. Because we're sorting the primitives, this should be a primitive attribute. And again, this is something that I'll just visualize with the color. So if you do atan 2, this is kind of like a dot product, but it's just like two-dimensional. So if I look at the x component and the, yeah, you're right, atan yx or xy. So you do this, and then you have like a clock, just a 0. I think it goes negative, +1 to -1, kind of like a dot product. There's other, I don't really know the math behind it and everything like this. Oh, that Houdini version is XY. Yeah, so I could switch it maybe. And then instead of having this, let me just find a visualization of this. So this is basically what it's doing. As you go around a circle, you give it the XY position, and it will give you this kind of like a sundial or like a clock relative to the kind of like polar or circular coordinates of that space. So yeah, so you could switch X and Y, I guess. I don't know exactly the math behind it, but it will just rotate things like 90 degrees basically. So instead of assigning this to at CD, what I can do is just make like a temporary value. You could just name it T. Now you see that I have this attribute on my primitives, or each face has this value that we were visualizing with the color, but what I can do is sort the primitives by it now. So these things now are sorted in like a clockwise fashion. And then when I go to my last step, now you can see that they're going this way. So if I go negative, now you can see that things are going the other way. And then this is closer to the actual end result. So the speed might be a little bit different and things like that, but we're headed in more or less the right direction. So just continue to kind of name things clearly. So I'll just call this like scaling shrink each face. Depends how verbose or whatever you want to be when you name these. Then this will be sort by atan attribute. Then this one will just be calculate sort attribute. And then if I just want to be really clean or organized, the last thing people usually do is just delete these attributes that they aren't using anymore. So if you're making a bigger scene file, or when you start like mixing and matching techniques, usually you don't want all these like debugging, or once the variable has done its purpose, or you've used it for what you're going to use it for, it's good to get rid of it just to keep like your geometry a little bit more simplified. This will just be repeat inwards. It's just our repetitive shrink that's making repeating copies. This is just our value that's just going to grow all of our circles using that like logarithmic scaling to make it expanding at a visually constant or linear rate. And then the last one here is our color mask. So now we've got everything we need. We just need to kind of do the last step, which is going to be scaling all of these faces. So there's different ways to do things, or to do this. Uh, there's different ways to do things in general. There's different ways to do this as well. So if you look here, we can scale faces using this primitive. Um, if I really wanted to, I think I could do like, type in the values here and use them, but this is using something called HScript that I don't really want to use too much of. Yeah, so I was doing this power of 2 or time plus 1. So I don't really know the way to explain it very well in terms of math or formulas, but to have things visually expand at a linear rate, I needed to do like 2 to the power of time instead of just multiplying things by time. So instead of doing my scale at a linear rate, or instead of doing my scale using HScript, what I can do is again do it using Vex. So this is just going to give us a little bit more control. Like per primitive, we can run slightly different code if we want to. We just have more low-level kind of control over things instead of using HScript, and I think it's also a little bit faster, depending on how like side effects has kind of optimized things. So I'm going to have this run over primitives because I just want to apply the scale once, but I want to modify the actual point positions. So we're going to have to do like a little bit of a more advanced thing. So what I can do is make an array. I'm just naming it PP. So that stands for the primitives of each point, the points of each primitive. So if I do prim points, this is a function that generates an array that has all of the points that belong to the primitive that you ask it about. So 0 is like the input, the incoming geometry, and then the primitive that I want to know the points of is just the current primitive. So this, you can't visually see anything yet because we're not generating any results. But what this is going to do is this will give me this PP array, which will be all of the points that belong to the current primitive. So if we want to actually do something with those points, you can do a for each function. This is like a special loop, kind of looping function or iterative function, and you can use it to do something to each of these points on the array. So I'll just set this up like that. So this will run over each element of an array. So I'm going to make a new integer that will be pt for points, and then what it will run over, which array do we want to have this run over, which is pp. So one thing that I can do now is like modify that points attributes. So if I do set point attribute, just do 0, like it, I don't know why they've set it up this way, but basically you can only modify the current geometry, but you also need to tell it that you're modifying the current, or 0, like this input geometry. And then what do I want, which attribute do I want to modify? So I could modify the point position with P. You could modify any attribute. You could do like color or anything like that. The point number, which is PT, and then the actual value that you want to give it. Yeah, that's kind of what I'm going to be doing eventually I'll get there. I'm just building things up I'm trying to kind of like set up the skeleton and then fill it out from there. So the last thing is like the actual value. So if I type in 0, then you could see what's happened is it's just set all of the the positions to 0. I might want to make sure that this is a vector. So you could see there it was just looking at like the first component. So one thing that I can do before that step is to read in the position. So if I get the current point position before writing to it, then I can like do some modification or operation to it. So I want to get the attribute value of the position. So we just do it like that. The same input geometry, the same attribute, and then we're just reading it, and then we're writing it with this step. So now I can get PT pose, whoops. And now we're not doing anything to it, we're just reading it in and writing it back out. And then if I did want to modify it, like multiplying it here by 0.5, then we're just scaling everything in half. So we've basically kind of recreated this operation, but we've just done it with like a little bit more steps because we only want to run our code over each primitive instead of each point. And the reason we're doing that is because we want to do it based off of the primitive color. Yeah, I'm using Linux Mint for this. Sometimes you run into problems, but just with like Houdini in general, I prefer to use Linux with like OpenGL or NVIDIA and all of that stuff. It just seems to run a little bit better. The other thing I like to do is like to, if your Houdini isn't running like properly and you need to kill it, you could get the process ID. I've never been able to figure out how to do that with Windows. Like I can never, so you could do this kill command on Linux with like segv or something as an argument, and that will basically force Houdini to make a crash file. So like here, if my scene gets messed up, I can still force it to save. That's the main reason I like to use Linux. Overall, it's kind of nice. I like the customizability of it. Yeah, so I'm just doing this per primitive now because I want access to both the color value, and then I want to use that color value of the primitive to modify the point positions. So instead of doing a constant scale everything by 0.5, what I can do is scale it by the color value. And color is a vector, so we could do that, or like you could do it with X, or you could do the red component of it. This stuff is black and white anyways, so either way it will work like that. But the problem here is that our scaling isn't happening properly. Like we're basically scaling things from the wrong pivot point. If you ever scaled something that isn't at the origin with Houdini, you haven't applied this like pivot. When you scale something, it will move towards the origin as you scale it instead of like moving it towards its local center coordinate or centroid or whatever you want to call it. So there's a few different ways to figure out like the centroid of the triangle for each face. The easiest way to do it is to just use the at P. So if you use this, let me see if I've found it. If you use this P, instead of at a point position wrangle, if you use it in like a primitive wrangle, it will give you the centroid of the face. I think that was it. Yeah, it's a little bit faster. You could compute it manually in a loop. I could go over that as well. But this is just another kind of shortcut, or I guess it's like more of a hack. I don't know where they had it. Somewhere it was like all of the I don't know where they put it. They used to have somewhere that had all of the like attributes that you could work with, essentially. Maybe it was this. Like they had the common, um, whoops, I don't want to do that. Yeah, I don't know. Somewhere they had all these common ones and what they were for. But basically, if you use at p instead of being in point mode, if you use it in primitive mode, it will give you what it finds to be the centroid of the current element that you're processing. Um, so what I can do is I basically have to move my point position to its local origin, which is basically just subtracting the centroid. Do my operation, do my scale, and then at the very end, um, move it back to the world space, like its original position. So now you could see that I'm scaling basically based on the center coordinate instead of before it was like everything was getting scaled with this being its pivot point or its centroid. And then just doing like order of operations here. I need to do parentheses to have it do this subtraction first, and then I do the scale, and then just because it automatically addition happens after multiplication, I don't need any more parentheses or things like that. The other thing I might want to do is like with my scale value, I just want to clean it up a little bit and make sure that it is between 0 and 1. So if I use this clamp function, that's like the quickest way to do it. So I can make sure that this is between these two values, and that will make sure that, like before it was, I could just apply that to the whole color value. So you could see before, without doing that clamp, I was getting some negative numbers. Basically, when I'm applying this offset of time, it will generate some negative numbers as things keep expanding. So I want to stop things from shrinking at 0 instead of going below 0. So that's how I'm getting this shrinking pattern. I guess we'll just save this for right now in case it crashes. I'm just gonna make this like Vex stream. I think, what is this? May 17th. Just in case we crash or something like that. But I'll just go over a little bit more. So because, if anyone has any questions now, because basically this is the step, this is the end step right now for trying to get something close to this image. So I think I've rotated everything like 90 degrees. If I want to just quickly fix that, the easiest way or quickest way, I guess it's 180 degrees. We need to do it to this one. So now this is more of like a one-to-one kind of match or getting closer to it. Yeah, so if anyone has any questions, feel free to go in here and ask them. I'm going to be posting this to YouTube, and I'll be sharing the scene file and stuff like that. I know a lot of this Vex stuff is like a pain to type out, and like without copy and pasting it can be hard to troubleshoot and stuff like that. So because we've taken these steps and set everything up in a procedural way, I'm just going to make some more of these. So I think I'm running out of like floating point precision when I'm subtracting them. They're not getting scaled properly, but it's okay for now. So I was just writing out my loop at the start of the scene to avoid that problem. But because we've set everything up this way, let me just go into like set my thing into just 3 seconds or a quicker timeline so that doesn't happen. So what I was saying is because we've set everything up in this procedural fashion, like I can generate other random shapes, just changing some of these starting parameters. And because this is looking at like the number of primitives in this input, it will always scale to fade things out of that ring at the same speed. I can do the same thing here with this remeshing to get different patterns and have a lot of fun with this. I can go back and just not do the remesh and do it with quads and kind of look at what that pattern looks like. I can turn off my sort function. I could do another sort function down here that might just be like random and try out different seeds and get different patterns and have some fun with things that way. I could change the way that I'm like dividing things up, so we could just do a subdivide like that. We do this loop-based subdivision that just generates triangles instead of quads. I can move these steps around and whoa, you can get like a dissolve, like data kind of effect that way. You can get a lot of different kind of like interesting geometric patterns or results pretty quickly with this kind of small setup or collection of subroutines. So that's why I like to kind of work in that fashion, just kind of keep things named. Just to finish it, shrink bases by CD value. So we kind of have these clean, like reusable pieces of code that we're doing. So sometimes I switch it to just alpha if I want like a black and white, purely black and white based image. Let's see what happens here. So you get just different interesting patterns. Visualize stuff in different ways and get a lot of cool kind of results this way. And then even some of these, just bypass all that stuff for now. So even some of this like lower level stuff, you can even dive in here and play around with it as well. So all these numbers like don't have to be fixed or they don't have to be the same. You can divide stuff, multiply stuff by all kinds of numbers and get like different crazy, sometimes things are more interesting than others, get all kinds of different results, come up with kind of new results or new outputs. That's definitely a fun part of Houdini. This speed and scale and all that stuff is parameterized, and you could kind of extend that and build in extra controls and extra parameters just to have kind of more control over this routine or the results or things like that. So I'm probably going to end the stream soon. I guess we got this done pretty quickly, like an hour, a little bit over an hour. But if anyone has any questions, feel free to, I could explain things like firsthand now, or otherwise just drop them in the comments on Twitch or YouTube later if you're stuck with something. I'll put the link to the scene file with the video and all that. So if you guys like the stream, feel free to share it with other people who you might know, they might find it helpful. I'm hoping to get back in the habit of doing these things a little bit more regularly and getting just more of a routine. I'm trying to make a schedule and go over different things kind of beyond Vex or different areas or different topics and stuff like that each time. I hope you guys enjoy the rest of your weekend.